Let's take a look at multinomial regression in action. Imagine that you have some preference and that you choose this preference based on covariates which are individual, your own covariates. This example is about this ENHANCE, the National Health Nutrition Examination Survey. It is a national program that collects data concerning the health of the population, and assume that N subjects are to select choice between K categories. And each subject would have 3 covariates, X1, X2, X3 for each of the N subjects. And given the covariates, can you model probability of a subject selecting the category K between 1 and capital K? Let's take a look at the model. This is multinomial distribution with one choice, with K categories, and the probabilities of categories are capital P to be modeled. This is a direct generalization of Bernoulli distribution. Bernoulli distribution would be only the choice between 2, no and yes. And then for each category from 1 to K, you say that this eta, which is linear combination for ith subject and category is J, is E raised to the linear combination. And then to find the probability, you take this eta and you divide by sum of all etas, simply to normalize this. So when you sum up all these probabilities with respect to J, with respect to the category, you will get 1. What you do, if you choose the first category to be your reference category, then the first category you set all coefficients, betas, B's in this case, because we call them B's, to be 0. And then we put the prior on the other categories to be, let's say, normal 0, 0.1 is the precision. With this, we fit the model. What we find the probabilities of the categories. It is fitted based on data that we got. So let's suppose that new subject comes and say, hey, I have these covariates. I say covariates 3x1, 3x2, and 30x3. And the question is, can you predict for me probability that I will select category 1, probability that I will select category 2, and so on and so forth? Well, simply, you plug in the covariates for this subject into the model. You get the linear combination for that subject corresponding to each of the J categories, and you normalize this to get the probabilities. That is simply P star J are the probabilities of categories J equal 1, 2, up to capital K for the subject having these covariates. How this was working, here we go. There are 10 subjects and 5 categories. And these 10 subjects, this subject, first one selected category 1, second selected category 2, the last one selected category 4. Now the covariates for these subjects are given by these values, x1, x2, x3. So you read the selection and you read the covariates and you fit the model. Now you need to initialize this. You need to put for B1 NA because you set this to be 0. And you put initial values for other B's to be 1. Now what these initial values are, this is category 1. These are probabilities for 2 and so on and so forth. The last column is initialization for the probabilities of the 5th category. And let's take a look at the results. We get that for this person who came with the covariates 3, 3, and 30, probability of selecting the category 1 was almost 0, category 2 about 4%, category 3 about 12%, category 4 about 68%, and category 5 about 14.2%. They should sum up close to 1. So let's take a look at the results here. Here we got for the subject that has covariates, the new subject that has covariates 3, 3, and 30, I believe. We found the probabilities of the 5 categories. That means that subject with these covariates will select category 1 with probability 0.006195, category 2 with probability about 4%, category 3 and so on and so forth, last category 5 with probability 14.2%. This should sum up close to 1 and essentially predict the probabilities for any subject with given covariates, the probabilities of selecting different category from the K selected categories. So as you can see, this generalizes the binary regression in which you have the binary choice, yes or no. In fact, you model only probability of yes, and then probability of no is automatically found as the complement. Here you see the box plot of the probabilities, and you see that actually the category 4 is favored by this subject given his covariates.